Hello everyone, I am Nikali from Fine Science 2. Today I would like to present Chapter 8 Mathematical Modeling. What is mathematical model? A mathematical model is a mathematical relation that describes some real-life situation. We also can say mathematical model is a representation of a system of scenarios that is used to gain qualitative and or quantitative understanding of some real-world problem and to predict future behavior. Mathematical models are used to solve many real-life situations like launching a satellite, predicting the arrival of the monsoon, controlling pollution due to vehicles, and reducing traffic jam in big city. In this chapter, you will be introduced to process a constructing mathematical model, which is called mathematical modeling. In mathematical modeling, a real-world problem will be translated into a mathematical problem. We then solve the mathematical problem and interpret its solution in terms of the real-world problem. Mathematical problems plays a part in many diverse professions like engineering, medicine, economics, geology, etc. It involves asking questions about the real-life problem, formulating mathematical representation, which depicts the actual situation via equation, graph, etc., and then extending this representation to learn new things about the situation. Let us look at one example of mathematical word problem on direct relation. Example 1. Mr. Kasim traveled 520 kilometers on 40 liters of petrol in his car. If he has to go by the same car to place which is 136.5 kilometers away, how much petrol does he need? Before we answer the question, we need to highlight the information that we have seen in the question. 530 kilometers with using a 40 liters of petrol. 136.5 kilometers use how much petrol? Here is a diagram for you all to easily to understand what is the question asking. Okay, start. Understanding the problem first. Let x equal to distance travel, y equal to amount of petrol needed. Given x equal to 520, y equal to 40, find the value of y when x equal to 136.5. Petrol needed for traveling 520 kilometers equal to 40 liters. Petrol needed for traveling 136.5 kilometers using how much petrol? After that, diversing a strategy. You know that Mr. Kasim's car travels, the more petrol is needed. The amount of petrol needed varies directly as the distance traveled. Y varies directly as x. So y equal to kx, where k is a constant. Substitute y equal to 40 and x equal to 520 into the equation y equal to kx to determine the value of k first. Then substitute x equal to 136.5 to find the value of y. Implementing the strategy. Y equal to kx, 40 equal to k times 520. k equal to 1 over 13, y equal to 1 over 13x. Equation 1 describe the relationship between the petrol needed and the distance traveled. Substitute x 136.5 into equation 1. Y equal to 1 over 13 times 136.5 equal to 10.5. Making a conclusion. Thus, 10.5 meter of petrol needed by Mr. Kamsim to travel 136.5 kilometers. Let's see the example 2. How long does it take to clean up an oil spill in the ocean? This example is quite different. We do not have enough information to answer this question. It is an open-ended question. We usually do not have complete information when trying to solve real-world problems. This real-world problem demands us to use both mathematical knowledge and creativity to solve them. In this case, mathematical modeling is perfect for solving such open-ended questions. There are a few important components in mathematical modeling. First, identifying and defining the problem means write down the information that you see from the question and what should you need to solve. Second is making assumption and identifying the variables means something that you accept as true without question or proof. Thirdly is applying mathematics to solve problem. After that is verifying and interpreting solution in the contents of the problem. Means you need to prove that something exists or is true, or to make certain that something is correct. You can use a graph proof. Later, I will show you what type of function to draw the graph. After that is refining the mathematical model, means to make something poor or improve something, especially by removing among the material. Last one is reporting the finding, means give a description. Mathematical modeling process. Okay, start. First step is identifying and defining the problem. After that, making assumption and identifying the variables. Then applying mathematics to solve problem. Then verifying and interpreting solution in the context of the problem. Until here, you need to ask yourself, do you need to refine the mathematical model in the question you are solving? If yes, you need to repeat at the first step. If not, you can directly go to the reporting the finding and then end. Linear function can be described with straight line. A linear function fx equal to mx plus c includes the rate of change m, an initial amount that is y-intercept c. After the model is written and a graph of a straight line is made, either one can be used to make prediction about future behavior. For example, telephone call charges, cost of renting a bike, weight management, or fundraising. Let's see the example. Water drips from a tap into a measuring cylinder. The following graph shows the height of water in the measuring cylinder every minute for 4 minutes. Here already give you the graph. You can see the graph is a straight line, so means that this graph is using a linear function to draw. Second is mathematical modeling with quadratic function. Quadratic function can be described with U-shaped curve called a parabola. The curve has either a maximum or minimum point. The general form of a quadratic function is f(x) equal to ax squared plus bx plus c, where a, b, and c are constant. Quadratic function can be used to model motion in moving projectiles and widely used in science, business, sport, and others. Let's see the example. A college is presenting a play. The profit P in RM after X day is given in the following graph. We can see the graph is growing in a U-shaped curve, means this graph is use the quadratic function to draw. The last type of the function is exponential function. An exponential function is a function of the form of f(x) equal to cx power of x, where a larger than 0, a not equal to 1, and c not equal to 0. The base a is the growth vector, x is a variable, and c is the initial value. The most basic exponential function is a function of the form of y equal to a power of x, where a larger than 0. When a larger than 1, the function grows in a manner that is proportional to its origin value. This is called exponential growth. When 0 smaller than a smaller than 1, the function decays in a manner that is proportional to its origin value. The function decays in a manner that is proportional to the original value. This is called exponential decay. For example, if a is 2 and 1 over 2 respectively, then the graph of y equal to 2 power of x and y equal to 1 over 2 power of x are shown in the following diagram. Exponential models are used in study of material population growth, radioactive decay, compound interest, cooling of objects, and growth of phenomena such as viral infection and internet usage. Okay, now example 3. Initial train A and B are 320 kilometers away from each other. Train A is traveling toward train B at 50 kilometers per hour, and train B is traveling toward train A at 80 kilometers per hour. Find at what time that the two trains meet. Solve this problem through mathematical modeling. Okay. Highlight the information first. Finding the conclusion. Train A to train B, train B to train A, what time? Okay. Here the question needs us to solve this problem through a mathematical modeling. The mathematical modeling process starts with identifying and defining the problem. So here for the diagram. And the question needs us to find at what time the two trains meet. After that, we need to make an assumption and identifying the variables. Assume that the speed of both trains remain unchanged along the journey, and both trains travel along a straight line until the two trains meet. The third step of mathematical modeling process is applying mathematics to solve problem. Let the starting position of train A is at the origin 0, 0. Since train B is 325 km away from train A initially, its position is 0, 325. Train A is traveling toward train B, which has a greater y value. Train A's rate of change must be positive and equal to its speed of 50 km per hour, that is positive 50. The train B is traveling toward train A, which has a lesser y value, giving B a negative rate of change that is negative 80. Thus, the equations involved are y equal to 50, x as equation 1, y equal to negative 80x plus the 325 as equation 2. The two trains will meet when the value of y are equal. So 50x equal to negative 80x plus 325. 120x equal to 325. X equal to 2.5. Therefore, the two trains meet after 2.5 hours. After the step number 4 is verifying and interpreting solution in the context of the problem. The distance time graph of train A and B is shown in the following diagram. You can see this diagram is using a linear function because it's a straight line. Okay, train A is represented by the equation y equal to 50x, and train B is represented by the equation y equal to negative 80x plus 325. The two trains will meet at the intersection points here, 2.5, 125, which is 135 km from the origin position of train A after 2.5 hours. The step number 5 is refining the mathematical model. Y equal to 50x and y equal to negative 80x plus 325 are the linear function models of train A and B respectively that satisfy all the constraints given in the problem. These models are not suitable to use in other situations. For example, if the train needs to stop at certain stations along the journey, these linear function models also need to be modified for different speed and different distance in between. Last step, reporting the finding. Report the finding in the form of problem solving based on the interpretation of solution that has been carried out as above. That's all for today's video. Thank you.
This is all of my presentation. Thank you for watching.